For this Zoom meeting, I didn't really want to go over any new information. I'm just going to use it to kind of go over the stuff that you should have gone over yesterday and today on ionizing radiation, and then on using EM waves to carry information. So I'm basically just going to do the same thing I did in the video and just talk about them, go over the PowerPoints. So if you feel like you got a good grasp of this stuff, there's no need for you to be here unless you want to just hang out with people. Or if halfway through you feel like you don't really need to be here, you don't need to stick around. Don't feel obligated. It's just kind of an optional way to get the information one more time. You should have gotten it by reading the notes. You should have gotten it by watching the video, and this is just a third way. It also gives you an opportunity to ask questions if you have any. All right, so don't be afraid to type something into the chat or to speak up and ask a question. Okay, so actually, before we get started, does anybody have any questions on what's due on Friday or anything that happened last week? Nobody? Okay. I did purposely try to start slow last week. I didn't try to overload you guys with too much stuff last week, just to kind of get in the groove of it. But we are going to probably pick things up a little bit coming ahead. So yesterday's topic was ionizing radiation, and we had this video for you guys to watch, and it talked about there's two different basic types of radiation. The first type are EM waves, and all EM waves are radiation. So radio waves, that's radiation. Visible light, that's radiation. X-rays and gamma rays, radiation. So all EM waves are considered radiation, and that doesn't mean they're dangerous. It's just a title that they are. The other type of radiation is from nuclear reactions. So when unstable isotopes radioactively decay, they will emit radiation. So nuclear radiation, all of that radiation is ionizing. It's dangerous. However, only certain types of EM radiation are harmful. Ionizing radiation is basically if the radiation has enough energy to dislodge an electron around a nucleus, it will strip that electron. So you can kind of see here, we have energy coming, hitting the electron, stripping it off. This can damage the atom, it could damage DNA. And so, like I said, all of nuclear radiation from decaying atoms, this happens with. But for EM waves, not all EM waves are ionizing radiation. So you can see here from this graphic, the only types of EM radiation that are ionizing are ultraviolet, X-rays, and gamma rays. So everything else, visible light, is not harmful to us. Obviously, it is not ionizing radiation. So even though it is considered radiation, it is unharmful, as is infrared, heat waves, microwaves, radio waves. So all of these are unharmful. They're non-ionizing radiation. And so once again, radio waves, microwaves, infrared, visible light, they have lower energy. And so because they have lower energy, they are non-ionizing. So even though they are radiation, not harmful, so their energy will heat up molecules. If you think about a microwave oven, so the microwave oven, the energy from the oven is going into the food. It's making the molecules in the food vibrate more. And so it can heat up molecules, but it doesn't really change the molecules. Ultraviolet, X-rays, and gamma rays, those have higher energies, and those energies are high enough where they can ionize the atoms and strip the electrons off. And so this can damage DNA. So there was another video for you guys to have watched, kind of talking about what happens when that occurs. And then there was an article about the radium grows. Did everybody get a chance to read that article?
Yeah, I did.
Yeah, I read it.
Any questions about it? Okay. Yeah, so basically radium was discovered and it was glowing in the dark. And so they were using it to paint the dials on watches. And in order to get the brush, have a fine tip on the end of the brush, they would put it between their lips and kind of lip it, and it would make the brush really fine tipped. And so they would do that in between painting the dials with this radium. And so they were ingesting little bits of radium. And most of them died pretty horrendously from the radiation they were ingesting. And this was at a time when we didn't really know the effects of radiation. They knew it was kind of a neat thing. It glue in the dark, but they didn't really know the harmful effects of it. So that's a good case study, kind of showing what can happen to our bodies with ionizing radiation. All right. Any questions with the ionizing radiation? I think it's a pretty straightforward concept. All right. If you have a question, you can always type it in the chat, or feel free to unmute yourself and speak up. So this was yesterday's topic, and today's topic is using EM waves to carry information. And you guys can all see the screen, correct?
Yeah.
Oh, okay, just making sure. All right, so the EM wave that we're most familiar with carrying information is AM and FM, radio waves. And so AM stands for amplitude modulation, FM stands for frequency modulation. And so this video kind of does a good job kind of showing the difference. Amplitude modulation, you're changing the height of the wave, and that changing the height is what's carrying the signal, carrying the information. And frequency modulation, it's changing the frequency of the wave. And I think this graphic kind of does a good job of showing it. So the amplitude, you can see the signal is embedded through the amplitude of the wave. And with FM signals, the data is encoded using the frequency. So areas have higher frequency means something, areas with lower frequency means something. So the wave is kind of carried along that wave using frequency, where AM, it is using amplitude. And so to kind of summarize the video, AM stands for amplitude modulation. The information is stored in the amplitude of the wave. We just mentioned that. The frequency remains constant, and it has a longer range. So that's one of the benefits of AM radio. FM stands for frequency modulation, so they're changing the frequency of the wave. The information is stored in the frequency. The amplitude remains constant. So once again, you can see here, amplitude is constant, but it's just changing the frequency. You can get higher quality, and this is because noise is represented as amplitude. So if you have an AM wave like this, and the amplitude goes up, it can either be data or it could just be random noise. And so the quality isn't as good. Where here, if you get a spike in amplitude, it's easy just for the radio to filter that out. It doesn't really correspond to data. It's just noise, and it can be cast aside. And also with FM, more information can be sent, and he kind of this guy kind of discussed that in the video. And then it's not just radio waves that we can do this with, because remember, all radio waves are just one type of EM wave, and so you can do this with other waves. And so lasers are a form of light, and so we can use so I mean, obviously, if you have a laser, you can see the laser. If there's particles in the air, you can see laser at the dot if it hits the wall or something. So lasers are visible light, and we can transmit information through visible light using using lasers. And so this guy kind of showed you how to do that. And then I had a video that I recorded last year that I also posted on Facebook, not Facebook, posted on Moodle, showing how I did it in the classroom. I was going to try to do a better job of kind of doing more with it, but the school is locked and I can't get into my classroom to do it. So I just used last year's video. So data can be sent, not just with radio waves, but with other types of EM waves. We can use data to transmit, we can use microwaves to transmit information. We can use infrared waves to transmit information. Remote controls use infrared. And some communications use microwaves. So all EM waves can transfer information, and they're doing that either through changing the amplitude, and they're putting the data in the amplitude of the signal, or through the frequency of the signal. And I think that was the last of it. Oh, one more slide. So other applications that use EM waves to carry information, barcode scanners. So barcode scanners, when they're in the device, when you run your item over the code, they're using light to pick up information or some kind of wave. I'm not sure if it's light or not, but they're using, I think they're lasers actually, to pick up the information. And it's carrying information. CD and DVD players also use lasers, fiber optic cables. So all of these are using EM waves to carry information, and they do that through adjusting either the amplitude of the wave or the frequency of the wave. And that is the end of the notes. So that was today's topic and yesterday's topic. Any questions about those? Okay. There were some questions for this week. They're going to be starting, I guess, today and tomorrow. A little bit longer than last week's questions, but I think they're definitely manageable. Does anybody have anyone started them or have any questions on them? Anybody have any questions on what we're doing at all this week? Okay. Chris is asking a question. How does information transfer through light? So I think the guy in this video kind of did a good job kind of explaining it. Like we know radio waves can transfer information, right? That's kind of like we're very familiar with this. And he kind of said that if you think about like Wi-Fi, Wi-Fi is not a radio wave, but it's also transferring information through the EM spectrum the same way. And so if you think of all EM waves are really the same type of wave, where if you think of like waves in the ocean and how you can have like little ripples in the ocean, and then you can have like surfing waves in the ocean, and then you could have like tsunami waves in the ocean. They're all different waves, but they're really just ocean waves. So EM waves are kind of the same thing, where you have radio waves, you have light waves, you have X-rays. They're all the same wave. It's just some waves are wiggling slower and some waves have more energy and wiggling faster. And so light is just wiggling faster than radio waves. So it's the exact same way that we can transfer information with radio waves. We can transfer it with light waves. It's just the light waves are just wiggling faster than the radio waves. But all EM waves are the same type of wave. Or if you think about like with slinky waves, like if you have the slinkies on the floor, we're making waves, slow waves, low frequency, faster waves, higher frequency, but they're all slinky waves. The same thing was true with the EM waves. It's just the radio waves are going like this, and the gamma rays are moving very fast, but they're all EM waves. So really, if you can believe or understand how radio waves can transfer information, then light waves is the exact same way. It's just light. It's just a faster wiggle of the wave. Krista, did that answer your question? Okay, awesome. Yeah, all EM waves, you can just think about them, they're all the same type of wave. Like I said, all slinky waves or all ocean waves or all seismic waves or sound waves are all the same type of wave. It's just we just call them differently because some have more energy than others. They're just wiggling faster. Awesome. Any other questions?
I have a question.
Yeah.
Are we gonna have quizzes or tests?
Yes.
Okay.
We are going to have a test. So it's been official that we are going to extend this distance learning through spring break. So that email was sent out by our superintendent, I think yesterday. So we'll have this week, and then we'll have 2 more weeks, and then there'll be spring break. And then at that point, they're going to reassess if we need to come back or not. So that Friday, right before spring break starts, there will be a test on waves. And we're going to have, like always, time to practice. I'll have some practice questions. I'm going to have a practice test, and the practice test is going to be in Moodle. So it will be the same format as the test, and you'll be able to take it as many times as you want, the practice test. But the test itself, it's going to be on the Friday before spring break. So it'll be not this Friday, but in 2 weeks, 2.5 weeks.
Okay.
Any other questions? All right. If you need help with any of the problems from this week, email me, or you can ask me now. You can also sign up for office hours Thursday, or you can join the chat Thursday and ask me. Same is true with the Tribusake corrections. If you want to fix those, you can do those individually. Those are due Friday, sent via email. So if you have questions on that, please ask. And the same is true with the wave quiz. So the wave quiz, if you need to redo that, send me an email with your corrections, and I will give you the password for that, and you can take that. And I think the important thing is just to kind of pace yourselves. Just do a little bit every day, so it doesn't all kind of pile up at once. And just continue to ask questions, because in class it's really easy to raise your hand, but here it's kind of hard to do that. So don't feel like you're overwhelming your teachers with emails. Just, it's important just to keep asking questions, because we're all here to help, and we're all here kind of adjusting to this. So next week, we're going to talk about sound. So we'll have 1 more week of sound. For honors, there will be a new math concept, and we're going to introduce it on Monday. We'll go over it on Tuesday. The Zoom session next week, we'll go over some examples together. And then we'll have practice problems on Wednesday and Thursday of next week with the math. And it's not super complicated. There's a little bit of a confusing part, but I think we'll be able to get it okay. But otherwise, that's going to be the end of it. We have this week on EM waves, and the next week is sound waves, and then we're going to review for the test and take the test. All right. Any questions for me? Everyone's doing okay? Does anyone have any questions from last week's problems? I posted the answers to those. You should have went over them and taken a look at them. We're all good. Excellent. Okay. That's it. Unless you guys have anything else. As long as you guys kind of understood last week and understood waves transmitting information and ionizing radiation, that's all I have for you guys. That's all this week. All right. So I'm going to stick around in case anyone else shows up, but you guys are free to check out and have a good week. Or you can stick around and ask me a question if you want, as other people drop out. Thank you.
Thank you.
Oh, was this helpful?
Yes.
Okay, it was more helpful than the videos that I posted. Okay, well I will continue to do this. I'll continue to do this, and I might change the day because it seems like there's some conflict with some other classes, so I might change the day or the time. But I'll try to do it once or twice a week, especially next week for when we have the math. Be at least once or twice I'll be on here to help you guys walk through the math. But I do have some videos explaining the math, and then I'll be on here to help you guys in real time. But otherwise, awesome. We'll keep doing this. Keep it up. Like I said, the important thing is if you have questions, please ask. Otherwise, have a good day, guys.
Thank you.
You're welcome.